Welcome back to a new episode of Passion for Technology, the podcast from EPD Electronic. Great to have you with us.
Welcome to the Passion for Technology podcast. In the smart factory, plant modules communicate with each other, machines control themselves, and processes become increasingly agile. At the same time, man and machine work ever more closely together, with cobots being a keyword. This impacts requirements for functional safety, that is, the protection of people and the environment from threats that can emanate from machines. Until recently, safety concepts have been very hardware-related and static. However, the modern smart factory needs dynamic solutions that ensure both the protection of people and machines and the necessary flexibility and availability for the factory to reach its performance goals. Our guests today are Stefan Strohmeier, Head of Safety and Security Solutions at NewTek. Hi, Stefan.
Hi, thank you for having me.
And Sven Blankenberg, Regional Application Manager, Central Europe West at EBV Electronic. Hi, Sven.
Hi.
Stefan, what does the Head of Safety and Security do at NewTek? What does NewTek do?
Yeah, NewTek is a development service provider in the field of industry and electronical engineering. So we're basically doing the development of components in large safety and security related systems. So NewTek is some kind in between of the semiconductor value chain, in between the EMS suppliers and the distribution. So our customers usually are manufacturers of components. My team, the team for safety and security solutions at NewTek, has the job to enable our customers to do those strongly regulated developments. So we're mostly doing conceptual works for our customers to ensure that all the regulative requirements are fulfilled and the needs from safety and security are harmonized in an overall concept. And of course, we do consulting, training, coaching.
Well, you know what? That leads beautifully to my next question, Stefan, and that is, how exactly are the requirements for functional safety changing as a result of Industry 4.0?
And that's a very interesting time at the moment because functional safety was very static over the last 20 years. And in future, the connectivity of devices will lead to a scenario where we cannot have safety without security anymore. And we have to react on the needs of embedded security in our safety projects, of course. And we will need the connectivity of the components for the needs of industrialization and automation. For example, we have the view of maturity grades in terms of industrialization and Industry 4.0. In the beginning, everyone wants to collect data and wants to monitor, condition monitoring, etc. And in the end, everyone wants to do some conditional monitoring and controlling the system. They want to control the systems and they want to write into the system. So we have to think about embedding the security today, which will be needed tomorrow. This is something which has already changed the regulations for safety and security. But this also changes the way we develop the project. So we have to keep the whole project lifecycle in mind.
One element of smart factories is a manufacturing structure in which different modules work together over and over again at varying locations, depending on the necessities of the respective task at hand. Sven, how can functional safety be realized for such a system if and when conditions and environments are under constant change?
The first thing is that we splitting the functionality in this kind of modular manufacturing, and that is a good way to reduce the complexity of the structure and help to make the module in himself more safe. But on another way, Stefan mentioned this before, and the new challenge comes in this functional safety scenario in the communication is the new challenge. And also this combination of modules, we have to create systems that are able to be safe in the future, but we can combine, that's the challenge or the both challenge for functional safety in general.
I totally agree. So the usual safety functions of sensors, logic, and actors will become more and more distributed to components of different manufacturers. And in terms of interoperability, it is absolutely necessary that they can find each other and provide the services, the safety functions they are providing. So we are thinking currently about something like a PubSub system where components are capable of finding each other and offering their safety functions to a central logic control systems, where the safety function then is configured. And this is, I think, the way where it will go in the next 5 to 10 years.
You know, the mental image that I have in my mind now is I'm thinking of a combinatorial explosion, thinking of all the permutations. I mean, does functional safety have to be evaluated for every possible combination of, let's say, space, time, and resources in advance? Sven, what's your take?
I think that every possible combination sounds for me like an academic question. We have to do this for each combination when we have to use it. The customer wants to create a new combination because he has more flexibility to do this in this way. Then we have to re-evaluate the functional safety features for the whole system. But through the modular components, we are able to do this very fast. We have a good time to market to change the factory itself. When you think about a nuclear plant, you have to nothing changing in a nuclear plant for over 20, 30 years. And that's the biggest issue or the biggest difference to the flexibility of our new modular factories that we have.
Thank you, Sven. Stefan, is it possible to realize safety systems that control and optimize themselves with respect to a specific work task?
I think there's still a long way to go, but I can imagine that this would be possible if the system has some kind of awareness and about the effectiveness of the safety functions which it can provide. But in this picture, we maybe miss the fact that humans will become very rare in automated production systems. So from my perspective, I think that the way to these self-optimizing systems and rearranging production sites and so on, this is still a long way. And until then, we will, I think, completely eliminate humans from the manufacturing. And if it is possible for some experts and service technicians to access those sites, I think there will be some kind of safety bubble. If it's active or passive, but the system will have some kind of awareness to detect people inside storage system, manufacturing system, and they will go to a defined safe state around the service technician, like cobots already do. And this approach will lead to less complicated safety functions and more to security, because security in those systems will become much more important, because this will affect availability of the system, of course, and therefore the productivity and, of course, safety.
Stefan, how does that manifest in reality from a technological point of view? I mean, does this mean that there will be even more sensors, even more communication and autonomous computing units for each module?
Yes, I think there will be additional functionalities, but they will be standardized, I think. And it will become some sort of commodity feature. So if you want to have your component installed in such an autonomous working factory, then standard features like today, like STO, safe torque off functions in automation, will be a standard. And from this perspective, I think it's not a lot more, but there will be a lot more of regulation and standardization to combine those elements together.
And Sven, would you say that individual components have to be equipped with even more integrated safety mechanisms than what's in use today?
I think we see this development in our semiconductor area over the last years. We create more diagnostic functions that are very, very useful or very, very needed for the functional safety as well. And these dedicated diagnostic features are tailored for the semiconductors, for the components and so on. And that will help to go faster to reach the goal for the functional safety features in this way. And this is very important for us, also for our customers, that we have the right functionalities to develop the functional safety in the systems as well, in the components that are multi-components as well.
Can the industrial sector learn something from the automotive sector? In principle, these production modules have to be able to act autonomously, similar, let's say, to a driverless car on the road.
That's a good question, because I have another question for that. How many autonomous vehicles we have on the street and how many hours autonomous vehicles we are on the road? And when I look on the industrial systems or machines, and I see a long time for industrial machines that we have already fully automated in the systems. is a little bit different. This is a different way, and we have several discussions with industrial customers and automotive customers to say, okay, functional safety is functional safety, but it's not the same, because the lifetime of the machines are different, the working hours from the systems are different, and so on. It's not comparable for us to say, okay, an industrial functional safety is the same as automotive functional safety, and therefore, yes, we can learn from each other.
May I add something to the last question? Maybe?
Oh, yeah, absolutely.
Because I think it's clear that automotive and industrial automation can learn from each other because they're facing different challenges. In automotive autonomous driving, we have to face uncontrolled environments, and they behave spontaneously. For example, at the moment, we have Carnival, and our car has to realize that this trash bin over there maybe is something who is dressed up like a trash can, and react on events which occur just out of nowhere. And in industrial automation, we have, of course, the opportunity to control the environment, and that makes it a lot easier. From the other hand, automotive is very specific. The standards are very specific because you always have to deal with a car or a bike or something like that. But in industrial automation, you have to deal with innovation. Each component can carry some new sensor technology or whatever, and you have to deal with this new technology. And so the industrial standards needs to be very generic in this approach. And so each one can learn from each other. For example, developer interface agreements are common in automotive as a document where you can specify who's responsible for this and that. And this will be part of the part 3 of IEC 61508 and the version 3, of course. Dependent failure analysis is a very good analysis tool for the rating of a maturity grade of a 2-channel system, which is better than in industrial standards. So we can learn from automotive a lot. And the structure of the standard, you can read it. The IEC 61508 in industrial automation is a network where you have to take a lot of time to orient. So, of course, there are things both can learn from each other.
Thank you both. I mean, that's been very helpful. So would you say, Stefan, then that the existing standards are sufficient to cover these new requirements?
Yeah, I think we have sufficient standards. They have to adapt to the current needs of the industry. For example, how to evaluate systems which are using artificial intelligence. Of course, they have to deal with those topics, but we definitely have enough standards.
Yeah. And the basic requirements of the standards are still the same, and the design principles are unchanged. That we have new technologies like AI and so on in place that is the game changer over the years, but end of the day, the standard requirement to save the user from the technology or protect the user from the technology is the main topic that we have to fulfill when we talk about functional safety. And therefore, we have a lot of standards. Too many standards sometimes because developer has to fulfill all these requirements in the standards as well.
And Sven, how can a distributor like EBV Electronic or a manufacturer of automation components, what can they do, what can you do to simplify the realization of flexible safety systems? How can time to market be reduced or even accelerated?
Yeah, it's the point. We have to differentiate between distributors and the manufacturers of components and so on. We as a distributor can help with our technical support teams to select the right parts, and we can help to catch the necessary documentation from our suppliers. But the system design, and here with the safety concept and the features as well, has to implement by manufacturers themselves. And this is the point where our partners like NewTek comes in, because 80% of the development for functional safety applications are conceptual processes and documentations. And this cannot be reached without support from these experts from NewTek. And therefore, we have these strong partners in our network. We help our customers when we find out that the customers start the first functional safety application to create a network, that we are really sure that the customers will reach the goals for functional safety in a short time to market. That's the point. We are from distributor, we cannot do too much as help and networking.
That's a very valuable partnership. So in this case, we, of course, take profit from the consulting we can then apply. And the projects can be also provided by modularization. So from our experience, we have derived platform solutions which will reduce the time to market because they are some kind of pre-certified or certifiable. So we have not only the template for some hardware solution, we also offer pre-certified libraries and the documentation and all the testing documentation to put it into an existing project and take profit from the preliminaries. And that's something where EBV also profits from because it's a shorter time to market and you want to sell parts, of course. So this is a win-win situation. And yeah, we're doing this for a few years now. And by the way, some concept where we can also learn from automotive is the safety element out of context, which is a common concept in the world of automotive. And this is something we will see in future in the industrial automation as well. So these are pre-certified components with a manual which tell the system integrator how to use it and how to reach the safety requirements.
Stefan, with all the efforts to realize autonomous manufacturing and with the advances that AI has been making and still is making right now, will machines themselves assess risks at some point?
That's a very good question. I'm sure they will certainly help us to identify risks, to assess risks, I think. But I truly hope that the consideration of whether the risk is acceptable for us as a society will hopefully remain with us humans.
Sven, different systems can only work together autonomously if they have a common data pool. Are component and system suppliers, also plant operators, ready for cross-company data pooling at all? What's your thinking there?
That's the holy grail over the time. Communication and interoperability are a dream science, my study in the 19th. We need it, but end of the day, I'm afraid it take a while that we have a harmonization over all systems and so on. We have a lot of approaches over the time, and we talk about a lot of technology definitions, but we have to bring all customers together. We have all partners in one boat, but it's not easy because we have learned over the last years, it's not so easy to catch this.
I mean, venturing into the future, how much autonomy will we see in the industry, let's say 25 years from now? What's either of your take? How about we start with you, Stefan? What's your vision for where we are in 25 years? And I'd also love to know, Sven, what you think.
That's a tough one. I think we will, of course, see a lot of autonomy, especially in manufacturing. So in manufacturing, I think there will be no humans be involved anymore except for services. That's something I would have as a wish because the work in manufacturing can be automized and should be automized. But as safety gets a commodity feature or no humans are involved, it's getting less and less important and security will be the big issue in future.
I think we are close to the 100% automotive factories in some areas today, but fully automated factories are more competitive and therefore reducing the cost and cost counts overall. And therefore we will go straight forward to these automated factories as well. But I'm not sure that I want to get a real 100% full automated factory for all this stuff because humans still more special features for diagnostics, more intentions and to avoid failures and unaccepted changes. The combination of both technology and humans will be the best solutions for me and will help us to grow in this area as well with the necessary functional safety. For a functional safety perspective, users have more motivation to protect from technology as the technology is from himself. That's the point why I think humans should be in factories as well.
Humans should stay in the loop and probably also stay in the loop because humans are certainly, as you say, more motivated and will remain more motivated than machines or AI, I suppose. And certainly humans are more passionate, I would say. And, hence the name for our podcast, Passion for Technology, where we also take about your respective passion for technology. So, Stefan, where does your passion for technology come from? And Sven, you will need to answer the same question. That's how we close each and every one of our episodes. And I, for one, very much enjoy and our listeners to hear where the origins of your passion for technology come from. So, Stefan, how about you start?
Yeah, I think that comes from my grandfather, who was a scientist. He was working in chemistry, and he did a lot of experiments with me at a very early age of 5, I think. And we have blown up some things, and we have done pretty interesting stuff. And he taught me things about electricity. So he was a well-educated scientist. And then I started studying biotechnologies. So I'm a marine biotechnologist and founded a company for software engineering. And now, 20 years later, I'm here and working with medical applications and sensors and tech. And it has always been a part of my life.
Yeah, for me, I started also with my grandfather to some things with electronic stuff and so on. And in the time that I have to decide what I want to do in my future, I see the robotics and automatic control as a good point to help to prevent or to avoid our community for too boring activities and so on. And robotics was one way for me to go straight ahead to help the community or to our society to move forward with all these things. And then I decided to learn the mechanic for measurements and regular automatic control. And then I studied this and go my academic way until to the distributor. And that's my way. And now we have a good solution for each things. And I think that's the passion that I have every day.
Those are beautiful origin stories, and you obviously can still hear that you are passionate about what you're doing. So thank you, Stefan, and thank you, Sven, for the insights that you've shared with us today. Dear listeners, as always, you can find more info in our show notes. Please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Sven, Stefan, thank you for joining us today.
Thank you.
Thank you.